afternoon, everyone, and welcome to another session of our MSME Masterclass. Today's discussion focuses on a critical but often underestimated aspect of industrial and construction execution, fasteners, and how failures in manufacturing discipline can quietly trigger costly breakdowns, delays, and safety risks on site. In many projects, the smallest components are often the ones carrying the highest operational consequences. When manufacturing precision, material quality, or installation discipline slips, the downstream impact can extend across equipment reliability, structural integrity, maintenance costs, and project timelines. To explore this topic in depth, we have with us Mr. Kaustubh Mehta, Director at Metaforge Engineering India Private Limited, who brings deep expertise in precision engineering and industrial manufacturing, joining us today. With an engineering background from COEP Technological University and years of leadership in advanced engineering solutions, he has been closely involved in building manufacturing systems focused on quality, consistency, and engineering reliability. His work spans engineering innovation, manufacturing excellence, and process driven industrial execution, with a strong focus on delivering high performance engineered components. He brings a practical understanding of how manufacturing discipline, quality controls, material selection, and process consistency directly influence performance outcomes and project sites. In today's session, he will share practical insights into why fasteners fail, where manufacturing and execution gaps typically emerge, and how MSMEs can strengthen quality discipline to prevent avoidable failures, downtime, and project disruptions. Thank you so much for joining us today, sir. We're pleased to have you with us.
Thank you for inviting us. Thank you for inviting me over here for JSW One MSME platform. And I'm very much excited to be here.
Thank you, sir. Thank you. So my first question to you is, how do fasteners become one of the most overlooked causes of structural and equipment failures on site?
Actually, first of all, I would like to say how people look at fasteners. I always say to my customers also and to everybody who is related with fasteners, it is a C-class item. But in a biryani, the spices are the most important gradient. It gives flavor and it plays a very, very important role in biryani. In the same way, fasteners are. Fasteners are C-class item, very less in quantity, but it plays very important role in the consideration of entire assembly, its performance. People should consider fastener development right from right when they start development of entire assembly. They start its development after everything gets developed. They feel it's very C-class item, small item, it can be developed within a night, which won't happen. So that is the most important reason why fasteners are most overlooked. But it can lead to major failures.
Got it. And so, what are the most common reasons fasteners fail during construction or industrial operations?
In that, I can say while manufacturing fasteners, process control is very important. So all processes are important. Like material selection is important, design of fasteners is important, in process forging is important. Thread rolling, heat treatment, and plating are mainly special processes. Those are also very, very important. So, good fastener is the effect of all controlled process. Result is good fastener. So each process should be properly controlled and properly validated. Then only you can get a good fastener.
Right. And how does poor raw material quality affect fastener performance and reliability?
It plays quite a major role because we had lost many big orders due to non-availability of good raw material in India. In India, raw material manufacturers are very less, and demand is very big, uh, in that they have huge orders for different types of raw material. And amongst all those raw material, fastener raw material is quite tricky, and they have to give more attention, more accuracy, but rate wise they don't get much as per their expectation. So raw material manufacturer don't pay that much attention for fastener raw material manufacturing, and that is the reason we many times get defective raw material. And these raw material suppliers are very big, so we cannot fight, or we cannot argue with them, or we cannot ask whatever we want. Customer, though we are customer for those raw material manufacturer, we cannot dictate. So there are many different types of failures. In 19, I think 98, we got a huge order for Japan. Maybe per month 4 to 5 containers at that time. But we purchased raw material. We sent one container. Customer was very happy. For next containers, we purchased huge raw material, and entire lot was defective. So big trouble for us also, big trouble for customer also. And then eventually we could not complete the order, and he again shifted to some other country. Currently also we are facing some problems with raw material, such as piping or carbon percentage, but we have to keep very close watch on it, and after checking inspection only we can give it to production. So that is a big challenge, and because of raw material, major issue can happen.
Understood. So, tell us, where do you think manufacturing inconsistency typically emerge in fastener production?
As I said, process control is very important. So, in engineering terms, 4M change, whenever 4M change happens, that means man, machine, material, or method. Any change, if happens, then there can be some issue. Not every time there will be issue, but there can be possibility of some issue. So sometimes we feel we are shifting machine from one place to another place. So everything is same, and dies also will be same, but shifting of machine also can impact on fastener. Material annealing process change also can impact on material, on final fastener. Sometimes we resharpen our dies, but that also can lead to some issue in threading, or issue in radius, or issue in chamfers, which can lead to assembly. And once we we were using forged component, and then we start because we had some die issue, then we forged somewhat 50% forged, and then we machined it. But because of that machining, there was some issue in strength, and customer during his assembly, he had some problems and could not fit the parts properly. So such problems can occur. In our case also, from plant 1 to plant 2, we shifted machines from plant 1 to plant 2. And when we shifted machines, on the same machine, we started forging. But we could not get the same results which we were getting at plant 1. So because of machine shifting also, it can vary. So you need to validate again, you need to ensure again. So these are the main forem change can give inconsistency in result.
So my next question to you is, how do you think heat treatment errors can impact the strength and durability of fasteners?
I think you have studied a lot for preparing questions. Heat treatment is, I think, putting a soul in fasteners. Because of heat treatment, the fastener can perform very well, and it can be as per that strength, whatever designer is looking for. So, if any issue in heat treatment, the batch can be problematic, and you cannot detect visually heat treatment issue. To identify heat treatment issue, you have to either go for very critical machineries like eddy current or so. Then only you can identify the defect. Otherwise, it's not possible to identify. But it can lead to major issues in field. So heat treatment is very crucial.
Moving on, sir, tell us what role do surface coating and corrosion protection play in preventing premature failures?
Surface coating is also important because 10 to 13 years back, in India, surface finish is just Dubau method tha. You just have to dip in different types of bath and black to yellow करना है, black to white करना है. इतना ही surface coating का importance था. But in last 10 to 15 years, in surface coating, India has improved a lot. Many auto plating plants are coming. Majority OE companies are demanding auto plating plants with SCADA controlled, because it is very important. It gives life to avoid corrosion, coefficient friction, and because of it also the thickness matters. If thickness is less, then also loosening of fasteners can happen. So considering all this, the surface corrosion is also important. Surface plating is also important. Surface coating is also important. If it is not proper, corrosion can happen. Because of corrosion, your part can be loosened, or it can be broken, or many times it can lead to multiple part corrosion also. The nearest parts of the fastener, they also get corroded. So this is very important.
Understood. So, how can incorrect fastener selection, lead to repeated breakdowns on site?
Pardon?
How can incorrect fastener selection lead to repeated breakdowns on site?
fastener selection can be from design perspective, right? Mm, Designer, yeah, such issues also can occur because of somewhat designers less knowledge about fasteners, or mm, he might be not knowing how fasteners are manufactured, how the what processes are involved and how they are performed. But because of this type of less knowledge, once at one customer, they called me for meeting with a designer, and he was asking me to forge parts with a rectangular wire, and from that rectangle he wants square section also, he want round section also, and quite a complicated part he was designing. I was trying to convince him for more than 2 hours, but he was not ready to accept my any experience or any knowledge. And at the end of that discussion, I have to say that you need to find some good fastener manufacturer and you have to try with him. And literally, he also instructed his purchase person to bring some better person. But after 2 3 months, I got different design with some changes in that, and the same application fastener was simple, whatever suggestion I have given. uh, I strongly feel that fastener selection, fastener design is very important from design aspects also, because he should understand how much strength will be required, uh, how much wear and tear will be there, what surface finish should we give, and many aspects he should think for while designing and selection of the fastener. Then only that assembly can give good results.
Right. And according to you, sir, tell us what are the most common installation mistakes that compromise the fastener's performance?
Installation mistakes. Okay. Mm, Installation. What you are thinking? Installation of machineries.
Yes.
Okay. These machines are normally high-speed machines, forging machines or any thread rolling machines, anything. And many times budget is also a concern. How we can manufacture with less cost and all. But in case of good fastener, just in an example I can give. uh, Chinese machines are quite cheaper, but at the same time Japanese machines are very costly, mm, almost twice or three times costly. But if we consider productivity or machine robustness, material metallurgy, everything is very perfect in Japanese machines. So eventually we gain from Japanese machines only. So while installing, all these aspects we should consider. One second, either in forging or plating, surface finish or heat treatment, any equipment when we install, mm, there should be knowledgeable person with you, because you bring like we had installed our first furnace. We were not knowing what other utilities are required for heat treatment. We just brought the furnace, but after bringing that furnace, we had to wait more than 3 months to install everything and to start that furnace, because we were not prepared. So while installation, you have to be have to have one good experienced person, and he can take care while installation, and everything will be perfect.
Right. And how important do you think are torque control and tightening discipline in avoiding failures of fasteners?
Again, it is important. I had one experience because our part was we were supplying our part to one assembly, and the same part customer started using for similar type of different vehicle assembly. But while shifting that part, uh, the torque applied for one assembly was different, and at other assembly was different. And customer found that for new assembly he was facing some problems, some issues. He then called us, your parts are defective. It's very common that in entire assembly, customer immediately blame on C class items in first. So he blamed us that your part is defective, and so rejection is getting, and lot of issues are there, etc., etc. Then we have to visit there, identify everything, and then we came to conclusion that the torque over here is different. That's why there is no problem in this assembly, and in this assembly torque is more, where for 8.8 class the torque should be less, but they want more torque. So they then redesigned that, and they asked us to supply with 10.9 grade. So then that was okay. But such issues can happen while if they don't design as per their torque. And torque, nowadays there are guns to give proper torque, and that is the proper method. In some cases I also observed at customer end, uh, for every part tightening they have record on their digital screen and IoT also. So uh, they are keeping that record also, okay, how much torque they have applied to every assembly, because it's important. So if torque is not applied properly, part may get loosened because of vibrations or in any motion, and it may get broken because of excessive torque. Fatigue will be there, and it can be failed in the field.
So you just spoke about vibration. Tell us, how do vibration and dynamic loads affect fastener integrity over time?
You have studied very deep one. Water fasteners. Uh, yes, there is an issue of because of vibration, such as loosening of fasteners. Then because of because of vibration, some wear and tear also can be possible. Then it can lead to some heat also. Continuous vibration that can create heat also in those fasteners or assembly. So because of that, expansion and contraction also can happen, and that also can lead to some issue in the assembly. And these vibrations also can be because of road shocks or any rotational movement or like that. So these can be avoided by using proper fastener, good quality fastener, or some Loctites, etc. and because of dynamic motion, also dynamic loads also, there can be micro cracks, there can be fatigue or sudden propagation of crack. So these can be issue in fastener. So need
Right,
to
right.
take care.
And so, how do you think MSMEs can? Why do you think MSMEs often struggle with quality consistency in fastener procurement?
I think many companies need a fastener because any assembly manufacturer can have requirement of fasteners.
And why? And what? Sorry, rather, what testing and quality checks do you think are critical before fasteners are dispatched to the site?
Yeah, in last 3 years, we had invested more than 3 crores in only testing in our lab. That is from spectrometer, UTM, and micro hardness testers, then profile projectors, and everything. So whatever for fastener is required, everything we purchased. But such kind of investment, everyone cannot do at initial stages. Uh, because of this, we cannot charge for our lab to our customer, and customer won't pay for that. But I still we can say, if you want good fastener, if your company is small or big, if you want to be assured, then you have to pay a little better price to fastener manufacturer. Don't go on kilo basis. That is very wrong way to get the fasteners. But if you select good fastener supplier, he has to have that all facility in house, all testing facility in house, uh, microscope in house, then hardness tester in house, uh, this spectrometer in house, and everything. Then in case of plating also, surface finish testing equipment, salt spray test chambers, then for crack detection, MPI machine, sorting machine, eddy current machine, everything should be there. Then only he can check all type of defects, or he can ensure the fasteners are defect free. So small companies, when they require fastener, their quantity is also less. So when they go to any supplier, they normally go to small fastener manufacturer. When they go to small supplier, then also they should get ensured that our fastener will be properly checked, either in-house, or they should check outside from agencies. So this checking should be there, either in-house or outsourced. But if it is not checked properly, there can be defect. And second thing, uh, even if small company procures fastener from bigger than his company, then also he should go and audit the process, whether he is following proper process, whatever he has given initially. So it is very important.
Got it. Now, sir, moving on to counterfeiting. Tell us, how can counterfeit or substandard fasteners create major safety and execution errors?
In testing and quality issues in manufacturing.
Yes, sir.
Okay. As I said before, when at forging stage, any operator changes the coil, at that time also there can be issue. Even a single fastener with wrong specification, if it goes in that bulk, it cannot be identified till we 100% sort it. But setting piece he can keep there only. These are majority are disciplinary issues, but discipline, because of disciplinary issues, it can create big claims in at customer stage. And while manufacturing, mm, even 4M changes are there. One person, the regular person was not there. Some another person produces the material. He don't know what specifications or what the minor precautions he should take. So we don't have those precautions and do something. So because of such issues, majority complaints are there in forging, in plating, or in heat treatment. But if you have proper trained people, proper senior people who can take care of all this, if any person is absent, then some senior person should ensure whatever happening is perfect. So if there are such checks are there, daily work management is there, then we can avoid manufacturing issues and defects.
So, talking about documentation, can you tell our attendees what documentation and traceability systems should manufacturers maintain for quality assurance of fasteners?
In India, recently that law is there. Previously, that law was not available in India. Because of anything, accident happens, its analysis and nobody claims for that. But I think before 4-5 years, one industrialist was died in the accident, and the person who was guilty in that, or his company, has to pay 17 crore. It was a court order. So nowadays that law is performing, and because of that, the traceability, identification, and record is important. Whenever any fastener was approved by customer, he approves the process also. You have to get process approved. After that, every manufacturer should control the process and maintain its data as per customer requirement. In some customer cases, it is up to 15 years. You have to maintain the data up to 15 years, and also the samples also you have to maintain as per those documents. If you don't have document and something happens wrong in the field, when that each and everything is checked over there, so which parts are as per not as per specifications, they find it. And in that case, if your part is not as per their specifications, then you will have to sell your factory, or you will have to accept big penalties, and which are nightmare actually. And in US or in Europe, it had happened to many companies, and that is not bearable. So documentation, and if you are perfect with your fastener process and everything, then nobody can touch you. So that's why nowadays documentation and even sample storage is very important.
And so, how do environmental conditions, such as moisture, heat, or chemicals, affect the life of fastener?
Yeah, it is important. It affects a lot, because in case of uh, whatever changes in surface finish happened, it is because of this only. Bajaj Auto or many customers used to export their vehicles to many countries, and during export they got complaints in various products, and because of that they improved their surface finish capabilities at all suppliers. So if there is a pro-corrosive atmosphere, it will 100% affect the fastener corrosion. So while designing fastener also, it should be considered for which terrain these fasteners will be used, so that they can think about which coating to be done. So it is important.
Right. And when we talk about coordination gaps, can you help our attendees understand what are these coordination gaps that could emerge between design teams or procurement teams and site execution teams around fasteners?
One major failure in this happens in coordination. Customer long back use one drawing, and supplier starts development. He produces samples, and then he gives to customer. Customer says some changes, then again he develops something. In between, customer has some other project priority. Time goes. Then in between, designer was working on that, and then all of a sudden, after 4-5 months, procurement team asks to give samples again. So supplier gives sample again because it is very urgent now. He prepares and he gives. After samples reaching over there, customer says, it is not matching with drawing. So supplier says it is as per drawing only, 100% as per drawing. Then he asks, which mod do you have? He says, I have mod 4. And customer says, currently we are referring mod 6. So this is quite common mistake from in coordination. If it is modified version, it should be reached out to supplier in time. So this is one issue. Second, at supplier end also, many times they could not give proper drawing to all process drawings, modified process drawings to each and every stage, and obsolete old drawings. So this can be a issue. One more issue is customer need it within a week or within 2 weeks, but he don't consider how much time it will take for die design, how much time it will take to preparation of die, logistic and everything. Then for forging also, raw material planning should be there. Forging day. That day also should be planned for sampling. So that is always gap is there. Customer need it within 1 week or 2 weeks, but supplier can give after 3 weeks, 4 weeks. So he then blames to everything whatever happening at supplier end. But he should consider, he should give proper time to supplier, whatever time is required. So at customer also he should plan early, so that he can get proper time and he can develop that those samples properly.
Got it. So, how can MSMEs balance cost pressures without compromising the fastener quality and reliability?
One thing is there, if you need a good fastener, all processes should be proper. One thing can small suppliers or fastener manufacturer can do one thing. He can focus on limited type of fasteners. Like if he manufacture say anchor bolt, so he should be master in anchor bolts, and whatever testing equipments required for anchor bolts he should have. He can outsource a little bit process from that, but for anchor bolts he should have testing, validation, everything, and then customer can get that benefit. But if he works for some aeronautical fasteners also, he is doing some braking assembly fasteners also, then he is working on suspension fasteners also, then he will have to install everything, but business will be less, and in that case cost can be more. In China, many fastener manufacturers have limited variety, but they manufacture in bulk, huge quantity, and because of that huge quantity manufacturing, their costs are less. So I feel MSME should reach to those fastener manufacturers who has bigger volumes of similar category. Then they can get a better price, but without affecting any testing or any shortcut of the process. There won't be. They should ensure that there won't be any shortcuts in testing and in manufacturing process also.
Got it. So speaking about standardization, tell us what role does standardization play when it comes to improving manufacturing discipline and reducing failures?
If there is no standardization, people get always confused. When it should use, how to use, and many more issues will be there. In case of parts also, if we standardize some on which machines, which fasteners we should manufacture, size wise standardization can be done. Then it's packing wise, packing also we can standardize. If there is more and more standardization, automatically the issues can be minimized. People are tuned. Every time they don't have to see or they don't have to ask to anyone what to be done. So standardization is very important. Because of standardization only, many mistakes and many issues can be minimized.
Right. So tell our attendees, what are the early warning signs that indicate that the fastener is, likely to fail, or there are failures that are expected on the site?
In the field?
Yeah.
Parts can be, fastener defects can be its elongation, loosening. Because of fatigue, it can break, it can bend. So one should one more thing, temperature can be increased of that fastener. So in the field, not everyone can check everything, but he can sense if there is a different sound of the vehicle. In construction assembly, he can check if there is some loosening is there, or some vibrations, more vibrations are there. If such issues he can observe, then immediately some detailed investigation or detailed checking should be there. Then we can avoid some major failures or major accidents.
Understood. So now my last question to you is, if an MSME wants to improve fastener reliability immediately, what are the first operational and quality measure it should implement?
I will say, if you want to improve fastener reliability, then you should think Metaforge fasteners. Robust process is one thing. Daily work management is second thing. Third thing, proper quality checking, proper special processes like heat treatment, surface finish, and last thing is proper testing, checking with proper equipments. If this is done, then your fastener can be good. At the same time, if you work, then some deviations will be there, but your team should understand where to give deviation and where should not give deviation. So that team maturity should be there. While manufacturing, there should not be any shortcuts or changes. If 4M change should not be there repetitively. So then only you can get a good fastener. So even your staff, employees, they should be very trained and good people.
That brings us to the end of today's episode. So thank you so much for being with us and for sharing your insights on why fasteners fail and how can manufacturing discipline prevent the costly site breakdowns. Thank you so much for being with us, sir. It means a lot.
Okay, thank you. Thanks from my side also. You invited me for this wonderful session, and I again appreciate you that you have studied a lot and find out very good questions for me. Thank you.
Thank you, sir. For our attendees who are online, if you'd like to view the current episode, if you've missed any part of the current episode, please go on YouTube at JSW One MSME and you will find all our episodes uploaded there. Thank you once again, sir. Bye-bye.
Bye-bye. Thank you.